this is Olivia over at Prepaze, and today we'll be going over our next section on our algebra unit for the introduction to functions. Now, what is a function? It's a relationship that defines between two variables. As a reminder, a variable is a representative value that we can plug in any series of numbers for. Typically, we use a letter like X, Y, A, B. Letters like that can represent a series of numbers, and we get to define what that amount is. In this case today, I'll be talking about a variable that is independent and a dependent variable. Today, my independent variable is going to be a number of unglazed donuts I have, and the dependent variable, which I will indicate as Y, is the number of glazed donuts. So what is a function? It is this gray box here, which defines how we operate on our independent variable in order to get our dependent variable. Let's talk a little bit about this independent and dependent. If I talk about independent variable being the number of unglazed donuts, no matter how much time or how much operation is going on, the number of unglazed donuts I have is not going to change. Let's just say, for example, my glazing machine is operating at full speed and we're operating fine. And so my number of unglazed donuts is not going to change. However, if my glazing machine stops, number of unglazed donuts is not going to change, but my glazed donuts do change. So if my function is not operating properly, my independent variable will not be affected, but my dependent variable will. We often call this an input versus an output. Now, how do we define the relationship between our independent and dependent variables? Well, that is where our function comes into play. We typically use an algebraic expression or equation to define the relationships between the independent and dependent variables. So let's have a scenario. Let's say I'm working at the donut shop and I have 60 donuts that I want to put through the machine today. If I'm operating under the assumption that my function is working properly, then if I put 60 unglazed donuts through the machine, I should get 60 glazed donuts out of the machine. So this is a ratio or a relationship. For every one donut I put in, I get the same donut out. How we would express that in an expression or an equation would be y is equal to x. This is our function. For every one x I put in, I'll output that same value in y. Let's look at another example between an independent and dependent variable. So this is a roller coaster that you typically can see at any given amusement park. And the two variables that we deal with is how high we are at any given point in time, and then time. Time is the ultimate independent variable. No matter what us humans do, it's always going to keep going. Nothing can stop time. However, if we look at our timeline at any given point, our roller coaster is going to be at a different height at any given time. So our height is dependent on how much time has passed. Let's just say our ride takes 100 seconds to complete. We start at ground level with a height of 0. We climb and we climb and climb. About halfway through the ride, we'll be at our peak height. Let's just say it's 100 feet in the air. And then as time continues, we'll continue down our line to the completion of our ride where we're back on the ground. So the function that defines the relationship between time and seconds will look a little bit like this. I exchanged my scratch drawing of a graph and exchanged it for a graph responding to a function. So I've put together an x value, which is our time in seconds, and I've defined a function, how we operate on x in order to get our y at any given time between the start of the ride to the end of the ride. Now, a function is not every single equation that we can put together. And in our next video, we'll define what a correct function looks like based off of what we call a vertical line test. I hope this was illuminating, and I'll see you in the next video.